Looking at ion charges. How do we deal with ion charges? Well, remember, charge depends on the protons and the electrons. Protons are positive, electrons are negative. So you can calculate the charge by doing the protons minus the electrons. Hopefully that makes sense. You subtract the electrons because electrons are negative. Electrons are negative. So that's why it's a subtraction problem. If you've got a lot of electrons, your charge will be negative. If you don't have quite so many electrons, your charge will be positive. You can rearrange this equation algebraically. These are two different versions of the same equation. All I did in this example was I added electrons to both sides of the equation. And then I subtracted the charge from both sides of the equation. So protons minus charge equals just the electrons because the charge canceled out over here. One thing to watch out for with subtraction problems and charges, sometimes the charges are negative, so you may need to subtract a negative when you do this. Remember, when you're subtracting a negative, you'll get a positive. An example here, chlorine often has a charge of -1. So if I'm dealing with chlorine with a charge of -1, I know that chlorine has 17 protons, otherwise it wouldn't be chlorine. And the charge is -1. So if I subtract that -1, that's like adding 1. So in that example, when chlorine has a charge of -1, you end up with 18 electrons. So that would be chlorine with a charge of -1. So let's do some practice problems. I'll do the first one with you, and then we'll pause the video with each subsequent one so you can stop and check your answers before each one. Example 1. If we have 35 protons, that defines the element. So that's my atomic number, and I look up atomic number 35 on the periodic table, and that is bromine, which has an element symbol of Br. I'll go ahead and put 35 in the bottom left corner because that's where I put the atomic number. Next up, mass number. Mass number, remember, depends on not on electrons, because electrons have virtually no mass. It depends on the protons and the neutrons. So I want to do the 35 plus 46, and when I add those two numbers together, I get, as my answer, 81. 81 is my mass number. I did not go to the periodic table and use the number 80 off of the periodic table. It's 79.90. I would round it off to 80. I don't do that here because I was told the number of neutrons. So I need to go with the information I'm given if I can. Now that I know that my mass number is 81, that's the number that goes at the end of my hyphen notation, and that's the number that goes in the top left corner of my nuclear symbol. So for a moment, it looks like I'm done here, but I'm not actually quite done yet, because if you look, the protons and the electrons are not the same as each other. Therefore, I'm going to need to put a charge up here in the top right corner. From the previous slide, hopefully we know that the charge is going to be the protons minus the electrons, again, because electrons have a negative charge. So that's how we calculate it. Charge is protons minus electrons. So in this example, I've got 35 minus 36. 35 minus 36 is -1. And so we write that charge in the top right corner of the nuclear symbol. Just to let you know, I will generally write the charge, the symbol for the charge after the number. That's just kind of standard notation. I'm not going to mark it wrong if you write bromine with a -1 charge like that. Another thing you will often see is not writing the number 1 at all, but just writing a negative sign. And so I would accept any of those on a test, but just so you know that these all mean the same thing. Pause the video and try the next one, and then come back and check your answers. If my atomic number is 35, my number of protons is 35, I must still be talking about bromine for question number 2 here. So I'm still have Br as my symbol. And, but I don't know, let's see, I wasn't told a mass number because it's not here or here or here. And I also don't know my number of neutrons. I don't have any information to help me figure out the mass. In this situation, it's okay to use your periodic table and take the mass off the periodic table and round it off to the nearest whole number. So for bromine, element number 35, the mass is 79.90. Rounded off to the nearest whole number, that 9 bumps the 9 up to a 10, which bumps the 7 up to an 8. So this is a mass number of 80. Mass number of 80. So we're going to write the number 80 here, and we're going to write the number 80 here. Just because it's bromine doesn't mean it's always the same isotope. It can have a different mass, and that's what we're trying to learn how to notate. I forgot to put the 35 for the atomic number in the bottom left corner here. How about number of neutrons? Remember, the neutrons depends on the mass number. Mass is the protons plus the neutrons. So my mass is 80, and that's my protons, which are 35, plus my neutrons, which I'm trying to calculate. What plus 35 equals 80? My answer here is 45, so I've got 45 neutrons. Not quite done yet. One last thing to check is, do I need a charge in the top right corner? The number of protons is not equal to the number of electrons. Therefore, I have a charge of some type. And it's the same charge as before because I do 35 minus 36 is -1. Now my nuclear symbol is complete. And you can try the next one, pause the video, and then come back and check your answers. Copper 65. I know that my mass number is 65, and I know that 65 will go in the top corner of my nuclear symbol here. The symbol, element symbol for copper is Cu. And with my mass number of 65, let's see, I looked up copper and I see that copper has 29 protons. So I'm going to write down 29 as my atomic number, 29 is my number of protons, and 29 as the number of protons on my nuclear symbol here. How about my number of neutrons? Neutrons are related to the mass number, so remember 65, which is my mass, that's going to be my protons plus my mystery number of neutrons. Subtract 29 from both sides of the equation so that I get my mystery number all by itself. 65 minus 29 is 36, so I have 36 neutrons in this example. I'm not quite done yet because my protons are not equal to my electrons. Therefore, I need to do a subtraction problem. Now, I don't actually like to rely on this equation. I can reason it out in my head that I've got one more proton than electrons. Therefore, I must have a charge of 1. Now, is it positive 1 or negative 1? I've got more protons than electrons, and protons are positive. Electrons are negative. Therefore, my charge must be positive 1. Once again, if your charge is just 1, we often do not write the number 1 there as part of the symbol, so I'm just going to erase the number 1. We can leave it as a positive sign, much like I said before for the negative signs. One last time, pause the video and try the last row of information. In the last row, we have 29 protons. That must mean my atomic number is 29, and so I have the same element as in the previous question. We're dealing with copper, which has a symbol of Cu. Now, is this still copper 65? Let me check. I'm not told a mass number. I'm not told a neutron number, so this might not be copper 65. I'm going to look on the periodic table and use the atomic mass from the periodic table. Copper's value is 63.55. So I'm going to take that number and I'm going to round it off to the nearest whole number. 5 bumps the 3 up to a 4, so this has a mass of 64. So this does have a different mass to the copper 65 version we did above. So we're going to call this copper 64. We're going to put 64 in the top left corner, and my number of protons, which is 29, goes in the bottom left corner. The number of neutrons is going to come out. I'm going to need to use the mass number to figure that out. 64, which is my mass number, is the protons, 29, plus my neutrons, which I'm trying to figure out. And if I subtract 29 from both sides of the equation, I get 35 as my number of neutrons. Lastly, my number of protons does not equal my number of electrons, so I need to think about what charge I have. Here, if I do 29 minus 27, I get a charge of positive 2. This hopefully makes sense. I've got more positives than negatives. I've got more protons than electrons, so my charge is positive. And I have 2 more protons than electrons. That's why the charge is positive 2. I hope this helped.